Alright, this is practice exam 2, and we're going to start at number 3. We don't get to use a calculator on this part, and you get roughly 15 minutes a problem, 4 total questions. So number 3 says a particle is moving on the coordinate plane. The graph of its velocity function is right here. So it says in part A, using midpoints of 3 subintervals of equal length, find the approximate value of 0 to 24 of velocity function. Okay, so you want to divide it into 3 rectangles. Okay, and if the whole base is 24, 3 rectangles would have 3 bases of 8. So our first rectangle would be from 0 to 8 on the base, and the second would be from 8 to 16, and then the third one 16 to 24. And then we're going to take the height of each rectangle at the midpoint of each one. So from 0 to 8, the midpoint would be 4. From 8 to 16, the midpoint would be 12. And from 16 to 24, the midpoint would be 20. So we have to read the graph and see what the height is for each one of those. So I went ahead to save a little time and wrote all this out. So you can pause the video if you want to write this down. But for rectangle 1, the base is 8. All right. If I read this graph at 4, the midpoint, okay, the height is 25. So that's at x equals 4. Rectangle 2, the base is 8. If I read it at the midpoint of that rectangle, which would be 12, the height is 15. And then for rectangle 3, of course, the base is 8. And if you read it at x equals 20, the height is 20. So the area would be 8 times 25, that's 200. 8 times 15, that's 120. 8 times 20, that's 160. So you would get a total of 480. So your answer for that question is 480. Now part B says, using the result in part A, find the average velocity. Okay, well we know that the average velocity is 1 over b minus a, so that'd be 24 minus 0, 0 to 24, v of t dt. But we know that v of t dt is just 480. So that's going to be 1 over 24 times 480. 480 over 24 would be 20. And then the unit would be feet per second. All right, part C says find the average acceleration. Okay, so the average acceleration is just going to be the slope. All right, the average acceleration would be not the slope at any particular point, but the slope of the secant line of this. Okay, so that's the slope that we're going to, if we were to draw a line, a secant line, that would be your average acceleration. Okay, so average acceleration is going to be the change in y over the change in x, or change in velocity over change in time, if you want to think of it from physics. So that's v of 24 minus v of 0 over 24 minus 0. v of 24 is 30, v of 0 is 0. So 30 over 24 would be 15 over 12. And that would be feet. That would not be, yeah, that is in feet. Yeah, sorry about that. Feet per second squared. Okay, let me see if I can squeeze D in here. Part D. What's the acceleration? When is the acceleration of the particle equal to 0? Well, acceleration is the derivative of velocity, so it's just the slope. Where is it equal to 0? It's where you have a horizontal tangent line. So that occurs at 6 and again at 14. All right, so at t equals 6 and 14 seconds due to horizontal tangent line. Okay, so not too bad so far on number 3. Let me erase that and get part E. Okay, part E says find the approximate acceleration at 20. So what you need to do is find the slope at 20 if you want to get acceleration. Okay, so I would probably just pick 20 and 18. Okay, so the slope at 20, so I would do 22 minus 18, those are 2 points that are right around it, over 22 minus 18. So V of 22 minus V of 18. So V of 22, just eyeballing that joker, looks like it's 25, and V of 18 to me looks like it's 15. So 25, that makes for easy math. 25 minus 15 over 4. So that's 10 over 4, which would be 5/2 feet per second squared at 20. All right, so I think number 3 is one you could get all of those. None of them are really too bad if you understand the graph. So you can get a lot of points on that one to help you out for ones that you end up missing. Okay, so that is number 3. Let's see if I can get number 4 in before the camera cuts off. We'll do our best. So number 4. So it says we have f of x is equal to 3e to the minus 2x squared. At what value of x, if any, does f prime of x equal to 0? Well, let's just get f prime of x and set it equal to 0. So that's going to be 3e to the minus 2x squared times the derivative of the exponent minus 4x. So that would be minus 12x e to the minus 2x squared. We'll set that equal to 0. And e to the minus 2x squared will never be 0 if you plug a 0 in. It doesn't matter what you plug in. But if we plug a 0 in for x, that'll be 0. So x is equal to 0 is where f prime of x. So that is the value of x. Hard to beat. How about f double prime of x? Okay, well, f double prime of x, we'll start with negative 12x e to the minus 2x squared. So it's going to be the first, negative 12x, times the derivative of the second. So times e to the minus 2x squared times minus 4x, plus the second, e to the minus 2x squared times the derivative of the first, negative 12. Alright, so that is going to be 48x squared e to the minus 2x squared minus 12 e to the minus 2x squared. Set that equal to 0. Let's factor out a 12e to the minus 2x squared. What's left? 12 will go into 48 4 times, and you also have an x squared left. And then if you factor out a 12e to the minus 2x squared, that just leaves 1. This term, never going to be 0. This term though, 4x squared minus 1 equals 0. 4x squared equals 1. X squared equals a fourth. So x will be plus or minus the square root of a fourth, which would be 1/2. The second one was a little bit of a pain, but I mean, you could do that. You've done stuff that hard. All right. Let's see if we can get C. So it says find the limit as x approaches infinity of f of x. So 3e to the minus 2x squared. Well, if we rewrite this as 3 over e to the minus 2x squared, actually it would be plus, right? If we move all that to the bottom, it makes the exponent positive, so plus 2x squared. And you plug in infinity, that's the same as 3 over infinity. If you plug in infinity, which is just going to be 0. So if we take the limit as x approaches negative infinity of 3e to the minus 2x squared, that's the same thing as the limit as x approaches negative infinity of the same thing, 3 over e to the 2x squared. If you plug a negative infinity into x and square it, it gives you positive infinity. So it's the same as 3 over e to the infinity, which is just infinity, which is also 0. So doing the negative, the x, you plug a negative infinity in for x and then square it, that's what makes it positive. So you end up getting 0 there. All right, not too bad. And part D, find the absolute maximum value of f. All right, well, we're going to have to go back to, in order to get a maximum, we're going to have to go back to the derivative. All right, so we found the derivative. So if f of x is equal to 3e to the minus 2x squared, f prime of x is equal to, let's see, it was minus 12e to the minus 2x squared. Okay, so it would be e to the minus 2x squared times negative 4x times 3. Okay. And we're going to set that equal to 0. Okay, so what is the maximum value? Well, I'm sorry, times negative 4x, so we would have an x in here. Let me rewrite that. Negative 12x e to the minus 2x squared. Set that equal to 0. Well, where is that thing going to be 0? Well, there's only one spot. It's when x equals 0. Okay, so our max is going to occur when x is 0. So, but that's not the answer. That's the x value. We have to plug that back into our original f of 0 to get the max. Okay, plug 0 into the original. That's going to be 3e to the 0, which is 3 times 1, which is 3. So our absolute max is at 3. All right, so we zipped through A through D pretty quick. And I can tell you that part E is one that you could do. There's a lot of algebra in it and everything, but it's really probably not worth your time. It would take a long time. It wouldn't give you many points. And it would take away from some that you would have time to work in number 5 and number 6. So let's just skip that one. So I'm sure you're not going to complain or argue with me about that. And there we go. Number 3 and number 4 is done, and I think you could have got most of those. All right, so we'll hit number 5 in the next video.